All right, in this video, we're going to learn everything you've ever wanted to know about velocity and some. Velocity is defined as the speed and direction of an object. Speed and direction. Velocity and speed are similar because they're both rates. Rate is the distance. Rate for speed is the distance traveled over some unit of time, while speed's part of velocity. So it's also in there as well. So it's telling you how far something's going to travel in a certain amount of time, but it's not exactly the same. Let's go through some of the similarities first, though. Velocity and speed are similar in that they can be both average, instantaneous, and constant. So just like you have average speeds, instantaneous speeds, and constant speeds, you can have average velocities, instantaneous velocities, and constant velocities. And they really mean the same thing for the most part. Average is the velocity over a period of time, exactly the same as it was with speed. A very general measurement that gives you an idea how the entire trip went, but tells you nothing specific. Instantaneous is the velocity for one single moment in time. So it's kind of like a snapshot. It was going on at exactly that time. It's a very, very specific type of velocity. It gives you no information, though, about what happened before or after that. And you certainly have no idea what happened over the entire trip. It's a very, very specific piece of information. If you need more review over what average and instantaneous means, go watch the speed video. I get into it a little bit deeper there. Constant is one that's constant. It doesn't change over time. But here's the little caveat. It's a little different. We know from learning about speed, when the time period is long, the average and instantaneous are going to be often different because it's hard to maintain the same velocity over a period of time, just like it's hard to maintain the same speed over a period of time. We know when the period of time is short, the average and instantaneous velocities will be very similar. The shorter the time, the more similar they'll be. Just like with speed, it's hard to change your velocity over a short period of time. And when the velocity is constant, the average and instantaneous are the same. Again, if you need more on that, go back and watch the speed video. Here's the caveat. Here's what's different. Constant speed means that just that rate, the miles per hour, the meters per second, that stays the same. And if you've watched the speed video, or if you remember from learning about speed, the direction is allowed to change when you have a constant speed. But velocity is vector. It said speed and direction. Direction is a part of velocity, and that makes velocity a vector quantity. Direction matters. So for a velocity to be constant, both the speed and the direction of the object have to stay the same. So it's not just good enough for the rate to stay the same, the direction has to stay the same as well. So for velocity to be constant, an object cannot turn. Now, if you watch the speed video, you know in that video I talked about a train going on a curved track. If a train is traveling on a curved track at a constant speed of 20 miles per hour, its speed is indeed constant because that rate, that 20 miles per hour, stays the same all the time. But you would not be able to say the velocity is constant because the direction of the train would be changing. So it would not have a constant velocity. This makes it tricky to find constant velocities. They're not as common as constant speeds are. There's also a difference in how it's calculated. Because this is a vector quantity, we have to use a vector quantity. The speed equation, speed with scalar, we use distance, the scalar thing. Velocity is vector. So we have to use the vector thing. We have to use displacement, which is abbreviated with an X. And again, if you watch that speed video, I was talking all about how there's only one equation that has D in it, because there's only one equation that has S in it. All the other equations have X because all the other equations are based on velocities. They have V's in it as well. So velocity is displacement over time, which would be abbreviated delta X over T. Change in position, that's delta X, that's your displacement over time. And again, if you need more on displacement, there's a video on that. You can go watch that and learn a little bit more about what displacement is. The units are the same, like they were for speed. It's the distance unit over the time unit. Difference is there's going to have to be some direction that's added to this. It's a little bit more than just that. There's going to have to be a direction in there, and that direction can be handled in words like north, south, east, west, left, right, up, down. Or you can use positive and negative signs to indicate the direction. Again, positive generally meaning the left to the right, up, north, that kind of thing. East. Negatives being used for left, down, south, or west. Either way, the sign ends up being applied to the displacement, and as such, it carries over into the velocity. So if you had a negative displacement, that means you would have a negative velocity. If you have a positive displacement, that means you would have a positive velocity. And again, that positive and negative sign just indicating the direction. So let's put it into practice, take a look at how some of this works. A boater travels due east and covers 50 meters in 13.5 seconds. What's the velocity of the boat? And again, using my uniform problem-solving approach, the first thing I got to figure out is what these numbers are. 50 meters. Now that could be a distance or displacement. Because I'm dealing with velocity, I know it's a displacement. So I write delta x equals, in this case, positive 50 meters, because the boat is traveling east, and east is a positive direction. The 13.5 seconds, well, I know that's time, so that's t. Now I identify if there's any hidden numbers in here, and there aren't any. Nothing's coming to a stop, nothing's starting from a standstill, there's nothing falling. Those are the key places you have hidden numbers. None of that. What am I looking for? I'm looking for velocity. Now, unlike speed, there will be many equations that have v in it. We have to pick which one's right for us. Early in physics, there aren't many, but quickly within a month's time, you have half a dozen or more equations that have v in it. We want the one that has v, delta x, and t in it, which directs us towards this equation. V equals delta x over t. I make sure I have everything. I need delta x and t. I've got both those things. So I can just substitute and solve. Delta x is positive 50. T is 13.5. 50 divided by 13.5 is positive 3.7. And I need to bring that positive with it. If I wanted to say east and use the word east, I wouldn't have to put the positive sign on it, but I'm not going to use the word east. So I'm going to put positive in there just to indicate the direction. Meters per second is my unit. So again, because I chose to write positive 50 meters instead of 50 meters east, I need to make sure I put that positive sign on my answer to indicate that direction. If I had written 50 meters east up here instead of using a positive sign, I would have put meters east here, and the meters east would have carried over here into the answer as well. And what I was said was meters per second east. Again, got to have that direction on there somehow. And typically in a CP class, I'd probably let them just use words like north, south, east, west. As I moved into the honors classes, I would give them options, signs, or words. In an AP class, you're going to need to use signs because I'm imagining that's how they're going to use them on things like AP exams. So a plane flies 1,000 meters to the west in 7 seconds. What's the velocity of the plane? Let's take a look at this one and see what's different, if there's anything. So I have 1,000 meters west. There's my difference. That would be a displacement of negative 1,000 meters. Again, I could have chosen to put 1,000 meters west as the unit on that, but if I want to use the signs, negative is west, just like left is west, or down, or left is negative, or down is negative. That negative sign that I'm putting in front of this indicates my direction west. That way I know when I get down here to final answer, I'm going to have a negative sign on it instead of writing the word west. 7 seconds, that's time. No hidden numbers. We're not starting at a standstill or coming to a stop or falling, the most typical places you find hidden numbers. What am I trying to find? I'm finding velocity. There we go. Identified what I'm given, identify what I'm trying to find. I'll look for the equation that has these things in it. That's the equation. And make sure nothing's missing. Nothing's missing. I substitute and solve. I let that negative sign stay right where it's at because that's my direction. Again, I could have wrote 1,000 meters west, but I decided to use negative in here because, again, that's what I would think honors and AP kids would do. CP students probably going to write meters west. 1,000 divided by 7, negative 1,000 divided by 7 is negative 142.6 meters over seconds for my unit. And again, I leave that negative sign on it because that negative sign is my direction that my velocities need. As again, I could have wrote 142.6 meters per second west, but the negative sign means west. Again, pretty simple stuff at this point. And if you watch my speed video, again, this is something a middle schooler could do. This is definitely not high school level stuff. The positive and negative direction thing, yeah, that's maybe a little bit more high school, but the actual math here is not complicated. And you know, this is physics, so we make things complicated. Let's take a look at how that works. A rocket is launched upward with an average velocity of 215 meters per second. How long will it take to reach a height of 3 kilometers? So we're just dumping right in the deep end here. And that's probably because I recognized that the speed video was going to be kind of long, and I didn't want to make this one quite as long as the speed video. So I just threw it all in one place here to kind of give you an idea of what physics can be like. Again, your results might vary. In a CP class, it might never get this hard. In an honors class, it could get this hard. In an AP class, it definitely gets this hard. So let's take a look. 215 meters per second, that's a velocity. So I will put that in my list. 3 kilometers, because this is a velocity, that's a delta x. We are traveling upward. Upward is generally considered positive. I put positive signs on both of those because they're both vector. Displacement is a vector quantity and needs a direction. Velocity is a vector quantity and needs a direction. So I put the positive signs on both of those this time. Again, I could have written kilometers up, meters per second up, and that would suffice. It would do the same thing the positive signs do. What am I trying to find? I'm trying to find how long. I'm trying to find t. If you watched my speed video and if you had me in class, you know that's a danger sign right there. T's can be tricky. Let's start with the first thing. I see a unit mismatch, kilometers and meters. And I know these things need to be the same. So I can either convert the kilometers into meters or the meters per second into kilometers per second. It's probably easier to convert the kilometers into meters. And for that, I can just do a simple metric conversion. Moving the decimal point, King Henry died by drinking chocolate milk. Again, you can absolutely use dimensional analysis here. We know 1 kilometer equals 1,000 meters because kilo means 1,000. And you can set up a dimensional analysis. You can do it that way if you want to. Thing is, by the time you do enough of the decimal point stuff, you get real quick at it. I look at that 3 kilometers, I need meters, and I just write down 3,000 meters because I know I'm going to go 3 places to the right because I'm that comfortable with the metric system. And I've been teaching science for over 20 years. I can do a metric conversion like that in my head, and I can do a metric conversion like that in a second or two. It saves me time. The more of these you do, the better you're going to get. So I'm starting at kilo. I'm starting here, and I want to get to the meters. Meters are a base unit. That is 1, 2, 3 places to the right. I take the decimal point, which I assume is on the end, and I move it 3 places to the right. So again, 3 becomes 3,000. Like I said, at first you might have that KHDBDCM on the paper somewhere, and you might be referring to it, and you might be drawing little arrows and stuff. After you do enough of these conversions, that pattern just gets stuck in your head, and you just think about it for a second, 3 places to the right, you move your decimal point, and you're done. And you can make that conversion in a matter of a second or two. And I know some high school teachers frown upon doing it this way, but the more you do it this way, the more you can just do it. Get it over with in your head. Instead of writing down 3 kilometers, you would have probably just written down 3,000 meters instead without doing any of the math on paper. And that's really where I want you to be. TV delta x is only one equation that has all 3 of those in it. And I do have everything I need to make that equation work. This is what I get when I substitute. Again, if you watched my speed video, there's a big red flag here. And that is the variable in the denominator. That's a bad thing. And before you pick up any calculator, before you start crunching any numbers, the first thing you've got to do is get that variable out of the denominator. And one of the easiest ways to do it is just to multiply both sides of the equation by that variable. When I multiply this side by t, the t cancels, and I'm left with the positive 3,000 meters. Left with a positive sign off of that. Add that real quick. Positive 3,000 meters. And when I multiply over here, I end up with positive 215 times t. And once you know, I left my positive off on that side too. There you have it. Once I've moved it, I can solve. Because here's the problem that even honors and AP students will make. If I leave the equation like this, they'll divide both sides by 3,000 and they'll say they're done. But the problem is that numerator doesn't disappear. That numerator just changes to 1. And what you solve for is 1 over t. You can see once you have it rearranged, you're not dividing by 3,000 at all. You're going to divide both sides by 215. Now when I take 3,000 and I divide it by 215, I get 14. Meters divided by meters per second, the meters will cancel, the seconds will move up. So 14 seconds is what I get for my time. If you want to see problems where I take it a little bit more step by step instead of just diving right into the deep end like I did here in velocity, you can go back and watch the speed video. The speed video is a bit longer because I take it in a step by step. So like the first tricky one is to solve for t. And then maybe the second tricky one is just doing a unit conversion, and kind of take it in step by step before you do all this at one time. Just notice I didn't put my positive on. There's no positive on this time. Never mind. Time is always positive, not negative. Except recently, physicists discovered that there may be an alternate universe where time does go backwards because they found particles that seem to be going backwards in time. So maybe in the not too distant future, there'll be negative time. But right now, there's not. It's not a vector quantity at this point. It may be at some point. But it's not a vector quantity at this point, so it doesn't need a plus sign on it. All right. What's this one? A person on the way to the store walks 15 meters north, realizes, oh, this is a displacement problem. Again, there's more than just unit conversions to do. There's more than just solving for variables in the denominator. Physics can be about going back to prior knowledge and using things you learned in previous units to answer questions in the current one. This is taking us back to displacement. Now, how do I know it's a displacement problem? 15 meters, 7 meters, 30 meters. I have 3 x's. Person walks 15 meters to the north, realizes they dropped their wallet, goes 7 meters south, then walks back 30 meters north to get to the store. I have 3 different x's. There's only one x in the equation, and I know that. So I know that I've made this trickier by adding something extra to it. The 2.5 minutes, that's our time. We want to know what the average velocity is, so we're solving for b. All these equations solve for average. Sometimes you'll see the word average in there, sometimes you won't. All of these calculations are average because they all involve something divided by time. They're all over a period of time. So again, let's take a look at what we've got here. We want meters per second. Very specific in this one. Meters per second. And we've gone off the deep end again. We've got to do a displacement problem, we got to do unit conversions, and then we get to solve a problem. So let's go ahead and convert. These are already in meters, so we know that's fine. Let's go ahead and convert that in minutes into seconds. It is a dimensional analysis problem, whether you write it down on paper or not. Some of you will just do it in your head. Most of you will just do it in your head. But it is really a dimensional analysis problem. You start with your given 2.5 minutes, and then a time sign. There's a fraction bar sitting right here. You know that by now. The unit that you have here is the one that has to go on the bottom of that fraction. So the 1 minute is going to go on the bottom and the 60 seconds is going to go on top. We do that for unit cancellation. I want that given unit to be on the bottom, so that given unit will cancel out. And all I'll be left with there is seconds, the unit that I'm looking for. The 60 is on top, so I multiply by it. 2.5 times 60 is 150. I could ignore the 1. I could divide it by 1 if I wanted to, but it doesn't do anything. Seconds is all I have left. So instead of using 2.5 minutes, I'll use 150 seconds instead. That way, when I'm done with my calculation, I'll end up in meters per second. Now, I could wait till the end to do that conversion, but I will be converting meters per minute into meters per second. And that's not going to be much different, but it is a little bit trickier to think about. So I like to get all my conversions done with first. That way I know in the end when I'm done with my calculation, I got the right thing. Only one equation that has v in it at this point has t and x's in it, but the problem is this is delta x. I got 3 x's. I got to figure out what the displacement is. And whenever I do a displacement, what I do is I add these 3 things together, including the signs. Now you'll note the positives and negatives. I didn't mention that. North is positive, so that's positive 15. South is negative, so that's negative 7. North is positive, so that's positive 30. I'm going to add all 3 of those together with the signs. So positive 15 plus negative 7 plus positive 30. I have positive 38 meters. And that's the number that's going to go into my calculation. At this point, just substitute and solve. The positive 38 goes on top. The 150 seconds go on the bottom. 38 divided by 150. 0.25 meters per second. I do need the positive sign on here. So make sure you include that. Indicate direction. Positive means north in this case, and that's why that positive sign is there to tell me I'm going north, not south. Again, I could have done it in terms of words, but with this whole thing involved, the signs are a much easier approach to solving that problem. So again, there you have it, taking you from the simplest of problems to the most complex of problems. How far yours will go in your class depends really on what level you're at. If you're on a CP level, you probably wouldn't go this far. You might not go this far. But if you're in an honors class, it's more likely. If you're in an AP class, it's definite. You're going to go this far. So kind of take what you can out of this video based on the level that you're at.